So now we're going to take a look at how when we provide discontinuous input splines like this, the pathfinding algorithm won't try to sort of path them all together as one path section. It will instead just path them as individual paths. It won't automatically sort of try to connect them up like it's currently doing. As you can see here, it gets to this point and it sort of bridges over here. So in order to just figure out how to solve this issue here, we need to think about what's actually going on. If we click on the find shortest path node, and actually let's go and preview we're going to set the points here after the wrangle. We're going to preview the point numbers so we can see 0 up to 6, and then it goes 7, 8, 9. And then if we just set this as well to sort of display it behind that, we can see that what's happening is at point 5, it appears to be going back over and joining up with point 7. This isn't actually the case, so I'm just going to clear up the sort of inputs a little bit here so we can see what's really going on. So I'm going to middle mouse and drag this point over to this side so we can see that actually it's routing through 0, 1, 2, 3, 4, 5, and 6 in order, and then 6 is the final point on the first curve input primitive, and then it's routing from 6 to 7. So the reason it looked like it was coming from 5 is because previously it was routing from 5 to 6. And then in order to get from 6 to 7, the cheapest path across the terrain was actually just sort of bringing it back along the path that it had previously taken, which can happen quite often with these kinds of pathfinding algorithms, especially when you don't have different costs in different directions. So we can see that, yeah, we're getting a connection from 6 to 7, which makes sense because we've just provided a list of points. We can see that we do indeed have a connection going from 6 to 7 here. So basically all we need to do is get rid of these two entries, 6 to 7. That will ensure that we have the pathfinding going from 5 to 6, which will give us the same result, and then it will give us the pathfinding going from 7 to 8, but it won't be doing in-betweens. So we need to modify the wrangle here so that it ends up creating a slightly different list. Okay, so how are we going to do that? We don't want to do it using the same approach we used previously because that's going to get a little bit complicated. It would be much easier if we could just create a string for the first path and then create a string for the second path. And let's just have a little look again. We'll turn on the primitive preview. We can see what we're working with. We do have two separate primitives. So we want to first consider primitive 0, and then we want to consider primitive 1. Okay, so we basically want to produce a bunch of different lists, but we do still need to concatenate all of those lists into one final list of start and endpoints. But we've got an idea now of how we might go and approach this. So where previously we are sort of considering all of the points of the entire geometry altogether, instead what we're going to do this time is we're going to consider first primitive 0 and then primitive 1. So let's just keep this wrangle alive, but off to the side. And we're just going to start afresh in a new wrangle and do something similar but different. We know that we still want to have a start and endpoints attribute, so we can keep that. And then we're still going to want to have a string B and a string A, but let's just not initialize those to anything for now. And we're probably still going to want to iterate over and remove some things from those two strings. We want to, when we convert from the array to the string, we're still going to need to remove these other tokens that don't really mean anything. Okay, so we're going to want all of those things. Now, where we start to diverge from what we did previously, where we expanded, we created an array of all the points in the geometry here. This time what we're going to do is we're going to create first a list of primitives. So we're going to call this int prims, and we're going to go expand prim group. And we're going to do exactly the same as we did before with the points, just this time for the primitives. So the first input to the attrib wrangle, and we're going to get all of the primitives on the geometry. Okay, so we have our array of prims. And just like before, we can say I at prims, or sorry, I array at prims equals prims, like so. And if we right click and go to the geometry spreadsheet, we can see that we now get a list of the primitives as stored as an attribute on the geometry. We don't actually want to output that as an attribute, so let's get rid of that line there. And now when we want to do things sort of sequentially, or we want to run over a set of objects, we typically do that using some kind of loop. So what I'm going to do is I'm going to say for each prim, so for each primitive inside of the array prims, we're going to do something. Okay, so that's what this loop is going to do. And then perhaps you've already guessed what we're going to do. If you thought that we now just basically need to take the logic that is inside of here and put it inside of here, inside the loop, basically that is what we're going to be doing. But we're not going to use the expand point group function. Instead, this time, what we're going to do is we're going to set int points to be equal to, remember it's an array, int points array equal to, and this time we're going to use something called prim points. Okay, so this is going to grab all of the points on geometry 0 for the current prim. Okay, so let's just make that look a bit neater. And now what we're doing is we're saying for each primitive in the geometry, we're going to get that points list. So now we can do what we did before, where we grab, we set string a to be equal to the points. Okay, so this is in the first primitive now. We're creating a string which is of that type, a string of those points, sorry. So we're converting from that array into a string, and then we're going to go over that array, over that string, sorry, and we're going to remove all of the tokens that we don't want. Okay, and then we are going to do the same thing here. So we're going to set string b to be equal to a, but we're going to skip the first entry, the first point, and then we're going to set a to be equal to the whole list, but minus the last point. So, okay, this is going over each primitive. We're doing what we did last time, so I can remove this now. And then we can set those to be equal to a and b. Now, the only issue here is that we're actually declaring these variables, a and b, inside of the for loop, which means they're scoped to the for loop, so they don't exist outside of the for loop, which is why we're getting the error. So we need to just, first of all, go and declare string a, string b, and I can then remove that shadow declaration there. And let's have a little look at the geometry spreadsheet to see what we get. Okay, so we're getting something, but obviously we can see that it's not correct yet. This is currently giving us a list of start and end points, but as you can see, it's only giving us the correct sort of list of points for the second primitive. So we go from 7 to 8, and from 8 to 9. So this is correct, but it skipped the first primitive for some reason. Why is that? Well, the reason for that is because with this for loop, we're just replacing the A and the B each time it's run. So we're not concatenating the results of each run of the loop into the array. We're just replacing it. So instead what we can do, and there are more optimized, more efficient ways to do this, but just for simplicity's sake, we can say start points and end points plus or equal to A and B. All right, nearly there. The only issue here is that we're not getting now the white space between those two lists. So what we can do now is we could say, hopefully this will work. We're just going to add a white space. There we go. Like so. Oops. There we go, just struggling to type there. And now we can see that we've got that space separated list. If we inspect the result, this may just work on its own, but if we inspect the result, we can see that we do get a white space at the front that we don't want. So let's just go and use the strip function. There we go. And we can just run that directly over the attributes endpoints. And we'll just need to set that as well. Now, it would be tidier to handle this slightly differently, so we're not just operating directly on the attributes, but I'll let you figure out how you can modify this code to do that. And for the time being, I think we should see that this is going to be absolutely fine. And whereas before, if we plug in the old wrangle, we were getting one weirdly connected set of paths. Now with the new one, we get those two separate paths, which is of course what we want. So there you have the basic setup that allows us to, with just one curve input or any number of curve inputs, sort of interactively draw and create paths across the terrain in the kind of manner of your choosing. And yeah, it's a lot of fun. It's nice to see it all updating live and being responsive. And even with quite a large number of paths, you'll see that this continues to scale pretty well. I'm going to look at how we can now sort of take advantage of this setup and not even dealing with sort of user drawn curves here, we can sort of dynamically, more procedurally create some paths across the terrain. So one way that we could look at doing this is if we go ahead and scatter some points across the terrain here. So it's quite a lot. So let's go down to 500 and then let's just create a single point sort of somewhere in the middle, like so. So we have a single point. And let's say we want to path from this single point to all of these other points. What we can do is we can go ahead and create a wrangle node, and let's go ahead and wire all of these points into the first input and then just that single point into the second input. And then for each point, what we're going to do is we're going to add a prim from our current point, which will be sort of 0, sorry, yeah. So geometry 0, we want it to be a polyline. We want to go from the current point number to this other point that we're creating. And this other point is going to be also created. So we're going to go add point. We need to make sure that we add it at a given position. So we're going to call that pos, and we need to get that pos. So sorry, in point. We need to make sure that pos is coming from the point that we've added here in input 1. So we can get that point by saying point 1, position P, position P, and that's going to be point number 0 because there's only 1. So we can say vector pos equals that. And now we can see that we have created a primitive between every scatter point and that single point there. So you could use another approach, but this one will work fine. And if we now go and wire that in to our wrangle that generates the names of the paths, let it cook, you can see that we've now created all of these dynamically generated paths across the terrain. And if we were to go ahead and just modify the sort of costing here, so let's just go and set the value of that cost to 1. You'll see that now it's just using the distance, so it's taking the straightest path between those points. But if we factor in the cost, we're sort of generating dozens of trails across the path at the same time. And if we decrease the number of target points, like so, you see that we start being able to generate these kinds of networks really quickly and easily without needing a custom setup for every different kind of pathing solution. So yeah, that's a sort of little glimpse of where we'll be taking this system in a little bit. And we're going to also be looking at how do we then sort of create effects like rivers, not just paths. Of course, rivers need slightly different logic governing the costs. They need to be able to consider not only the cost of being on a slope, but the relative cost of traveling down a slope versus traveling up it. And that also has a bunch of other applications. So that's what we're going to be looking at next.